It's a great pleasure to have you here. And this is the Department Information session in Physics and Astrophysics. So here's the plan for this evening. So for the first half an hour, we are going to introduce the Physics and Astrophysics programs to you. So I'm Rafael Fernandez. I'm the Director of Undergraduate Studies for the Physics major. We also have here with me Professor Lilia Williams, who is the Director of Undergraduate Studies in Astrophysics, and Professor Shaul Hanani, who is our Director of Career Education. So, and then from 4:30 to 4:50, we have a panel discussion with four of our current undergraduate studies, Juan, Salvis, Ben, and Virginie. And then after that, we're going to come back to a Q&A with the faculty. Okay, so please feel free to ask any questions. We're happy to answer any question you have. So, whoops. Okay, so let's start by discussing a little bit here. Why would you major in physics or astrophysics? Okay, so the core of physics is about understanding complex phenomena and then finding simpler explanations, right? So I like to give the example of Halley's Comet. This is a picture actually of the Halley's, or this is not a picture, this is an embroidering that you can find on the Bayeux tapestry from the 11th century. This was just the Halley's Comet was seen, and this was considered as an omen. This was just before the Norman conquest, okay? But what is interesting is that, now we understand very well what it is, and with very simple laws, Newton's laws, we can understand and predict the period and when the Halley's Comet is going to come back. And, for that, actually, even despite of the complexity, there's just a few laws that we need for that. So this is one of the things that give us, a lot of, that's what drives a lot of the physicists. But in the training, physics actually prepares you for challenges in a much broad range of areas. Okay, so you're not going to be just be prepared to solve physics problems, but to solve problems. So we like to say that we train you on how to solve problems. And what's very important, as I was just telling you, is that doing physics is fun and exciting. Okay, so. Here are the components of the physics major. So there's a core component which involves mathematical, physical, theoretical tools corresponding to three major areas of physics: mechanics, electromagnetism, and quantum mechanics. And we go well beyond just theory. We have hands-on experimental courses that teach you how to do data analysis, to conceive a project, and not only conceive it, but also execute it and present results. We have a quantum lab and the methods of experimental physics that Professor Hanani is going to tell you more later. There are lots of electives, and the electives then specialize a little bit in the different areas of physics: particle physics, condensed matter physics, biophysics, astrophysics, mathematics, materials, computation. And we are very proud of our research experiences that we provide to our undergrads, because this really maximizes your experience. And even if you're not going to do research in that area, just doing research and being in that environment and learning the steps of approaching a problem and solving it is very, very important and extremely useful, right? And we offer, we have a career committee, a career program that Professor Hanani is going to tell you about, which is going to tell you a little bit more about the career preparation that we offer for a next step, whatever it may be. So we actually have a very flexible program. There are 5 emphases. There's what we call professional physics, which we usually, a lot of our students take it, especially the ones that are interested in pursuing graduate school, but not only. Then we have more specialized ones: biological physics, physics for engineering, physics for teaching, and computational physics. So if you join our major, you're going to choose one of these 5 emphases. I'll now introduce you to Professor Williams. She will tell us a little bit more about the astrophysics major.
Hi everybody, thanks. So yes, I'm the DGS for the astrophysics major, and let me say a few words about that. So the foundations of astrophysics are the same as those of physics, so mechanics, electromagnetism, quantum mechanics. The big difference between physics and astrophysics is that in astrophysics, our experiments, our laboratory is the rest of the universe. It's not something that you can contain on a tabletop in your physics building. we study the rest of the universe. But the foundations, the wonderful thing about astrophysics is that the foundations are the same. So the courses that we offer in astrophysics range from introductory to upper division courses. And so in addition, what you have learned from physics as your foundations, you will also learn specifically about planets, stars, galaxies, clusters of galaxies, the universe as a whole. And the courses, in addition to these various topics, the courses also cover theoretical, computational, observational, and experimental aspects of astrophysics and the relevant bits of physics as well. So the whole range, basically. One of the requirements of the undergraduate astrophysics major is the senior thesis. So this is something which is required of all astrophysics majors. Even if you double major with something, we still ask you to do that. And we believe that it is a very good way of understanding how research, how actual work in the science is done. So independent senior thesis is done in collaboration with a faculty member, and the topic is decided upon in consultation with that faculty member. So my advice to you is to start looking for an advisor early. Don't wait till the last week, and it's a lot of fun. Senior theses are a lot of fun. And finally, astrophysics major is easily combined with the physics major because a lot of the courses are overlaps between the two. So back to Raphael.
Thank you. Yeah, so we talk a little bit. Okay, you talk a little bit about research, and that one of the things that we do very well is provide research opportunities for our undergrads, and we have all these different research areas, research directions. So I'm going to talk a little bit about them. We have the area astronomy, astrophysics, and cosmology, and space and planetary physics. They are part of what's called MIFA, the Minnesota Institute for Astrophysics. And Professor Williams is going to tell a little bit more about this. She's part of MIFA. And Professor Hanan is also part of MIFA, but he's on the physics side of MIFA. Then we have biological physics, condensed matter physics, which is my research group, or I'm part of the condensed matter physics research group, elementary particle physics, nuclear physics, and physics education research. So, and just putting here some examples of recent undergraduates that actually did very successful research projects here. So in physics, we also have the honors thesis, as Lilia Williams, Professor Williams also mentioned. But in physics, that's not a requirement, but we encourage our students to do a senior thesis as well. So Kelly Stifler, who is here pictured in Large Hadron Collider, LHC in CERN in Switzerland. So that's where her honors thesis work was related to LHC. There's also, besides the honors thesis, there's also independent directed research course. So you can just do research directed by, as the name says, one of our faculty. This is Brandon, who was characterized instrumentation that he is doing that right now, that will be used to measure anti-reflection coatings of telescope lenses. And these are telescopes to measure properties of the early universe. So we see how a very specific research task that fits in something very big. And there are other opportunities of research that actually involves the Europe, which is the University Undergraduate Research Opportunities Program. Here is Sam. Sam actually created an interesting model that predicts when coronal mass ejections will hit the Earth. And these are important because these ejections actually can be potentially dangerous, can create potentially dangerous sunstorms. There's also our undergraduate students also participate on the RU programs. This is an NSF, National Science Foundation sponsor program called Research Experience for Undergraduates. It usually occurs during the summer. And in contrast to the Europe, that's where our students will go to a different university to do research under the supervision of a different group and be exposed to a different environment. So Charles Brown, who was a UMN student, for example, he did an RU studying something called quantum dots at the University of Chicago, right? So that's when, again, so the Europe, you do research here, in the RU, spent a summer doing research in a different institution. And now I'm going to give it back to Professor Williams, that will tell us a little bit more about research that is being done in the Minnesota Institute for Astrophysics.
Thank you. Yes. So a few words about that, just a few specific areas of research. I won't cover everything. So one of the important aspects of astrophysics is getting observations of the universe, everything from planets to very distant galaxies. And University of Minnesota and our institute have access to this world-class telescope, which is located in Arizona and called the Large Binocular Telescope. You can see pictures of it on the left. You can judge the scale by the treetops. It's a huge thing. Each mirror is 8 meters in diameter. And on the right side is the inside picture of that very complicated instrument. So we get data from that, and some of the students analyze it as part of their research projects. So next slide, please. Thank you. One of the broad areas of topics that we study in astrophysics is how the insides of a galaxy work. So what role do stars and gas and dust that make up the galaxy work with each other to generate what we see as galaxies today? And this is a complicated cycle, and it involves stars at different stages of their evolution. It involves the nucleosynthesis, so the generation of chemical elements, which is going on at the very cores of stars. Eventually, the stars explode, and well, not all, but some stars explode and send the chemicals that have been generated inside of them into the medium around them, into the gas and dust. And later, that material gets incorporated into the next generation of stars, and those stars explode, and the cycle continues on and on. So hence the red arrows that trace out the cycle. And this is a complex and fun cycle to study, and a lot of work is being done on this topic. So yeah, next slide, please. This is another set of examples. So on the left, I have here, it's partly a calculation, partly an artist's conception of two inspiraling black holes. Each one of them is spinning, and they're obviously very massive and very compact. And in general, black holes are a consequence of general theory of relativity. So when they inspiral, they generate gravitational waves, which is something that we have been able to detect just in the last few years. And our institute has a group which is working on analyzing these data and figuring out what we can learn from them. On the upper right, you have an image taken from the Hubble Space Telescope, and it is an image of a gravitational lens. So background sources get distorted and imaged into multiple images by the foreground lens, and we can study the distribution of dark matter in the galaxies using that sort of information. And in the lower right, we have a schematic of a sort of a timeline of the universe starting from the left and going to the right as the universe evolved, and various processes taking place, including how the universe went from being relatively neutral in the early universe to being highly ionized in the present day. So these are just three very different topics that we study in astrophysics. Next slide, please. This is space and planetary physics, which we also have an active group working on that. And this is studying the Earth, the Sun, and the interaction between these two. And one of the most spectacular consequences of interactions is the aurora borealis, which is what you see a picture of that here on the left, otherwise known as northern lights, which you can actually see from Minnesota sometimes, not very often, but you can. And on the right, you see a group of students in Professor Glesner's lab who build small satellites that are launched into space to do various experiments. So, right, so I think I'll stop there and pass it on to you.
Thank you. So let me tell you a little bit about the research done in physics. Condensed matter physics is actually the biggest area of physics. It encompasses a lot of different problems. If you really like, to be on a lab and doing tabletop experiments, that's your area. Or if you want to be a theorist like me. So it covers from superconductors, which are these materials that conduct electricity without any loss at very low temperatures or not so low. You probably heard also things that have been going on now, an effort to develop quantum information science. We also have groups actively working on this field. So it is a very broad area with a lot of different things that a lot of different topics for you to work. And they actually go from from more applied topics to also more fundamental topics. Or, maybe you're like me, you like a theory. That's exactly what I do. I'm a theorist. And if you like to play with complicated equations and use a computer to solve it or something else, or just pen and paper, we have very strong groups doing theory in particle physics, nuclear physics, condensed matter physics, and so on. We also have a very active group on biological physics. They will study all sorts of different problems, for example, viral assembly, or they also end up doing work on this area called microfluidics. Here's Jonathan Morris, who actually conducted research as an undergrad in experimental biophysics. But here is an example of how a training in physics can prepare you for a lot of different career opportunities. He was actually selected as an American Institute of Physics matter science policy intern. So he spent a summer in DC working with Congressman Robert Andrews. We also have the particle physics that I mentioned to you. Here's Dino. He was actually with other undergraduate students working to build these detector modules on this experiment called NOVA. Okay? NOVA is an experiment that detects fundamental particles called neutrinos, and it's quite impressive. The neutrinos are generated here in Fermilab, which is near Chicago, and then they are detected here in Ash River, which is a very north of Minnesota. And the idea, there's another detector here called MINUS, which is in the Sudan lab. So it's a mine, actually, it's an underground lab. So this is one of these experiments that is trying to understand the nature of these fundamental particles called neutrinos. And the Minnesota has been doing a lot of hands-on work in building really this instrumentation that is very complex and full of rich physics. Now I'm going to pass to Professor Hanani, who will tell you a little bit more about careers in physics, which go well beyond just academia, as he will tell you.
Okay, thanks. Hello, everyone. So many people ask, even if you love physics, either your parents or yourself, you say, okay, that sounds great, but what will I do with the bachelor in astrophysics or in physics? So if you look at our graduates, about 50% go to grad school, and that grad school could be in physics, it could be in other areas. Some go to engineering, some go to a medical school, depends on what you do, but this is all part of the 50%. And 50% go to the job market, or sometimes people take a break. That's part of the other 50%. And that distribution 50-50 matches the national average. That's what happens in most big universities in the nation. So if you were going to go on the job market, so if you go to grad school, you pretty much know what your future after undergrad is going to look like, assuming you get accepted. You're going to spend 5 to 6, 7 years and get your PhD, or perhaps 2 years to get your master's. But if you go to the job market, what can you do then? Either with a BS in physics or with astrophysics. Next slide, please. So here are some concrete examples. All of these people that you see here have graduated with BS. The majority of them have graduated with BS in either physics or astrophysics from the program here. Of course, we have many more. We couldn't put them all on the page. Toby, on the top left, has gone to work with a medical devices company. You could see by the faces, you could see who was more recent, who was a little bit less recent. And Toby was in my class 2 or 3 years ago. Evan had become a financial analyst. He's one of our non-graduates, but he's become a financial analyst. Further diagonally to the right, Brian is a vice president of operation at Luminetics. He's actually part of a startup. He started up this company together with other people. Straight up to the top, Jessica has graduated just last May. She has got an internship with a law firm through our program in the Twin Cities. And then she got hired. They were very happy with her, and she got hired just about a month ago to work full-time, not as a lawyer, but perhaps she will do a law degree later on. Ian on the top right, he had gone to work at Fermi National Lab. So some people do national lab work. And if you go down, Mark, he has done only an astrophysics degree. Jessica actually has a double degree, physics and astrophysics. Mark was just astrophysics, and he has been in a number of jobs, using expertise. And most recently, he's a process engineer in Medtronic. And all the way further to the left, we do have some number of students. Jeff had worked in my lab 10 or 15 years ago as an undergrad, and then he went to become a high school teacher. He's a high school teacher at Blake, one of the private schools in the Twin Cities. So broad range of careers, very wide range of employment opportunities. And the key thing to remember is that the astrophysics training, and I'm using astro or physics, it gives you skills to simplify, generalize, and solve complex problems anywhere you go. And that's a highly valued skill in almost any field. Next, please. Here's an example of companies that have hired recently from our BS graduates in BA. And sort of they're grouped in categories: medical devices, various known companies in the environment. Perhaps you know some of them, perhaps not. Our graduates have gone to financial consulting. Yes, physicists go to financial consulting as well. Of course, the big tech on the top right, Seagate, 3M, Intel, who doesn't know about those companies? And various other companies. This is a small subset of companies who have hired recently of our graduates. Next, please. So how do we prepare you for your next step? Not just, oh, you have a concrete next step, but how do we prepare you? And so we have a unique program here at the School of Physics and Astronomy. It's unique in the college. It's quite unique in the country that we actually have a career education program that prepares you for your next step and helps you get your next step. So we are engaged, we organize career panels, we organize company visits, we help you in terms of your graduate school application mentorship. We are now starting this program to associate a current grad student with you when you are either a junior or a senior and thinking about grad school. So it's a program we're starting now. I'll talk about the capstone class in the next slide. We have talks and seminars. Just yesterday, we had a talk by someone who came to talk to undergrads and grad students about various careers. And we help with internships. We help you with your CSE career fair preparation. About 3 or 4 weeks ago, we had someone from Honeywell come to talk about students about how to prepare for the career fair. And if necessary, we help you, associate you with a mentorship as part of the CSE mentorship program. Next slide. So this slide talks about the capstone class. It's really a fantastic experience. Every physics major, it doesn't matter which emphasis you have to go through the methods of experimental physics. It's effectively a capstone class for physics. In that class, you develop an experiment from scratch. You don't have a manual. We don't give you a manual. You come up with your own idea, or you use one of one of a set of ideas that people have used in the past, that's fine. But you build the experiment from scratch. You put it together, you analyze, you collect the data, you analyze the data. Once you do that, as part of the class, we take you through communicating your experiment, communicating your results in both presentation, written poster, writing a report. Part of any career you're going to do in the future, whether you're going to go to grad school, you're going to go to wherever you go, effective communication is really important. And so this capstone class is a fantastic experience for anything you're going to do in the future. Next slide. That's back to you, Rafael.
Thanks, Shaul. So as a, if you come to our major, our department, there is a very active departmental community. So involved in a lot of other extracurricular activities and clubs across campus. We have a Society of Physics students, SPS, and actually you're going to have the opportunity to talk with some of our undergraduate students that are part of SPS after this presentation. And we have also the Astronomy Club, and both actually provide academic and social opportunities. There's study groups, cookouts, outreach to high schools, lots of different activities that interest the undergrads. We also have the Women in Physics and Astronomy, WIPA, is a group that provides networking opportunities and social activities as well. And what we're going to do next, we're going to hear the experience of some of our current students in the physics and astrophysics major from our panel. And then after that, Shaul, Lilia, and I will be here to answer questions that you may have about the program and research in the program. Okay? And we'll be trying as much as we can to answer the questions on the Q&A as they come up. And just the last thing I wanted to say is that if you visited our buildings, you see that they are very nice, new. The Tate lab of physics, where it's not new, the lab, but it's being renovated and it's very nice. It was being remodeled, and there's lots of nice space for not only for classrooms, but also for research. And we also have the physics and nanotechnology building, which is a very short distance from the Tate lab. As you can see here, this was a new building very recently built that has 43,000 square feet of modern and highly flexible physics labs and laboratory support. And also have this amazing nanotechnology space with what is called a clean room. So yeah, I would be happy also if you want to tour this labs to just contact us. So I'm going to stop my share here, and I want to invite our panelists to just join here with their cameras. And I will first ask them to introduce themselves, and then please ask questions on the Q&A, and we will read to them and they will share their experiences. So I'm going to just start in the order that I'm seeing here in my gallery view. Regini, you can go first, please.
Okay, hi, I'm Regini. I'm a second year and I'm an astrophysics major. So something that brought me to astrophysics was, well, I really liked physics in high school and everything, and I was really involved in my local astronomy club. And so astrophysics, kind of like the more I learned about what specifically is in astrophysics and what you learn in astrophysics, I was kind of more appealed to that. But so far, since I'm a second year, I'm in those base physics classes so far. And yeah, that's me. Bye.
Thank you. I have next here Ben.
Hi, I'm Ben. I'm a physics major, and what attracted me to the physics major was just the insane depth that you can really get into some of these topics in these classes. It's really exciting how in your earlier classes you might gloss over something, but then in your later classes you really hone in on that, and you really get all of the juicy details about various topics. And I find that really rewarding to learn and just develop further develop an understanding of the way the universe works. That's really satisfying for me. So that's what attracted me to it, and that's why I keep coming back.
Next year, Salvis.
Yep. Hi, everyone. My name is Savis. I'm in my final year of majoring in physics and math. A bit about my background, I guess, why I chose to be a physics major. I guess coming into my first year, I really only had two things to work off of. My best subject was math, not physics. But I also knew that I wanted to do research in a basic science. So that kind of drove me away from just being a math major. And I actually like the physics major more now because it gives me something that's a little bit more concrete. It's a really good mixture of math and just a basic science. And, you know, I'm still here 4 years later, so I definitely enjoy it.
Okay, Juan.
Hello, everyone. So I'm Juan, and I'm a third year, and I am doing physics and astrophysics. And one of the things, the reason I really enjoy this program is, well, I'm in it is because first I learned, I guess the first time I kind of looked at it, it was just through space, and I always found it like very fascinating. But the more I kind of was in this in here, is I started to realize that there are so many ways to attack a problem. There's so many ways to solve or a solution to something. And something like that was like, I guess, solving those puzzles that there's so many ways to do it is, to me, like the most coolest things you can do in physics. And that's kind of why I'm still in here.
Okay, so please send your questions to the panelists, to our students. I see here there are some questions. Shaul has been very quick in responding to them. Let me just bring this to the panelists to talk a little bit about this. So an anonymous question was about how common it is to get to work for big research labs like Fermi or CERN. So I wanted to broaden this question a little bit and maybe ask if you are doing some research. I know you're in different stages of your undergrad. Some of you are just starting, some of you are finishing. So maybe you can just share a little bit about how it is to do research, what kind of research you did, and what is your overall experience with the research. And I'll let whoever wants to say first to go ahead.
Yeah, so I can go first. I imagine I probably have the most experience here, just based on age. So I first got into research at the end of my first year. I actually had some professors come and speak to our 1402, 1302 class, and they said they were looking for undergraduates. You'll notice that there are a lot of opportunities for undergrads here at the University of Minnesota. And that professor was Professor Dan Dahlberg, and I've been working in his lab for about 2.5 years, give or take. And so he's doing condensed matter work. So just with my projects, I've had my own individual projects kind of ranging with a few different topics. So I've worked on stuff like polymers, I've worked on magnetism, and now I'm looking at noise. So I'm trying to decrease the noise in some very important components that we use for microscopy and stuff like that. So that's just like a basic background of what I've been doing. And what I really enjoy most about it is kind of a degree of freedom that we get that I'm not sure how programs work at other schools, but I know just from talking with some of my friends in the major and from my own experiences, I feel like there are a lot of opportunities for you to kind of have your own project or work very closely with a grad student or postdoc. And you really learn a lot just by doing things hands-on. So it's not really like you're part of a factory. You kind of have some sort of control over your own research.
You're muted, Rafa.
Yeah, it was on purpose. Let me follow up to the other panelists. There was a follow-up question here, which is, how can you get involved with research in your first couple of years? Or is it most common to participate in research in junior and senior year? So maybe one of you wants to say a little bit more about when you got involved in research, or when you want to get involved in research, or how you're navigating that.
I can do this. I recently got involved in research. As I mentioned, I'm a second year. Last year, it was a bit harder to get a research opportunity as one might expect given the global situation. So that was one of the things that I really wanted to get involved with this year. So what I did is I looked at, I'm primarily interested in biophysics. So I looked at a list of biophysics professors on the university website, and then, just typed in their name to Google to find some recent publications and tried to find some professors whose work really interested me. And then I just reached out to them over email and was able to get a position. So I would just recommend looking for projects that pique your interest and then emailing the professor to see if they have a position available for an undergrad.
I know, Virginia, Juan, do you want to add something to this?
Yeah, so,
Great,
okay,
go ahead.
so a lot of programs, I guess, will require like a little more advanced knowledge, but there's always like ways to find, there's always opportunities for like, I guess everywhere. But there is a lot of researching and like, there's a website, I don't remember exactly, but you can look up where each professor and what their their research is about. And it's a lot of the importance is just emailing and try to get them, and I guess they're your attention, or at least show that you have some interest in it. And there is a lot, but not so much on the first 2 years, but there is definitely opportunities to look for.
So
Sorry, I think
I just,
Virginia,
Rafael?
sorry, I think Virginia wanted to also say something before we move to.
Oh, I guess, well, I did a lot of that last year too, just like going on like that website and like looking at what, at least like all of my professors were doing their research in. So I talked a lot to like Ko Wang about his research. He was my physics 1 professor. And then just getting involved in like that's a really good place to start, getting involved in what your professors are doing, even if it's like not joining in, just like finding out what's going on at the university.
Shaul, do you want to say
Yeah,
something?
I just want to say that on that issue of first year, second year, don't wait for your major senior. By all means, start as freshmen. You might get, you might not, depends. There are various things. Don't wait. Certainly, you could start a freshman. I had many students started working with me as freshmen.
And I'm going to just piggyback on this. There was another question here. If you're pursuing a major unrelated to physics or astrophysics, if you can do physics or astrophysics research without having a double major, yeah, you can always reach out to the professor and talk to them. I mean, it's not a prerequisite that you're a physics major. You see, there was a question here that I really like, and I'll ask Salvis to answer because he's been working in a lab, as he said, for 2.5 years. So the question was, what exactly does it mean to work in the lab? Is it exactly as it sounds? Your professor has a lab and you are free to use it when you're doing research? I've always wondered how it works. I think it's a great question. And since you've been working there in Dan Dalberg's lab for more than 2 years, maybe you can give a little bit of perspective on that.
Yeah, so my experience with it, well, it would be wonderful if I could just walk in and do whatever I want and use all of his really cool equipment. That's not super, that's probably not super productive. Rather, how it works for me is, so I'll have a talk when I'm trying to decide on a new project. He has some projects in his mind that he will give me the option to choose from. So it might be like 3 or 4 different projects. I choose one that I find interesting. And then from there, it's kind of, it's almost like a help when I need it, but otherwise I'm almost on my own. So I have this one goal. I'll have a goal of like accomplishing my project. I'll be setting up my experiment and stuff like that. And I'll try to do that as much as I can on my own, because I think that's the best way to learn. But then you will also check in with your PI, your principal investigator, every so often, just to make sure things are still, you're still making some sort of progress. But I guess to make a clear answer to what is it like to work in a lab, you have, that's a hard question. It kind of differs from people. It's really, it differs from lab to lab, but for me, it's just try to get your experiment up and running, try to take data. You run into problems, you get stuck, you can go ask for help from the grad students and the professors, but it's not like just a super free-reigning process.
Yeah, so if I can complete, right? So I think Salvis mentioned this nicely, that you're not going to be working alone, right? Because a professor will have a group with graduate students, postdocs sometimes, and there's, you know, there's all this co-working that happens, right? Let me move on to the.
Can I
Hold on. Do any of the panelists want to add something here before I move on to the next question? Yes, Joe.
So the flavor I got from the question is, do you actually get to work in the lab? And the answer is yes, you actually get to go and work with instrumentation and put things together and measure things on your own. So in that respect, the answer is absolutely yes. As Salvis says, you don't just do whatever you want. You talk, you interact with the grad students, with the professor. You know, more often, less often, that depends on the group. But yes, you're actually there with the instruments doing stuff with your own hands.
Okay, so there's another question here that I'd like also to bring to the panelists. Oops, I lost the question. Were your respective majors what you had in mind coming to your first year, or have you switched to your current majors? If you changed your major, what led you to making that change? So I want to open this to whoever in the panel wants to take this question. If you just share your experience, we can start with this time with the people that were starting, they're in their second year now, maybe Rajini or Ben, or both actually.
Sorry, which question are you reading off of right now?
I accidentally moved the question to answer, but it's the question here. Were your respective majors what you had in mind coming to your first year, or have you switched to your current majors?
Okay.
If you changed your mind, what led you to making that change?
Okay. Well, coming in for me, I knew that I was going to go into astrophysics, and that hasn't changed. But I think that was just very much because of like all the stuff that I did before coming in, and I knew like what I wanted to do. But like just talking to some of my friends, the more like classes you take, the more you find out what you like and what you don't like. Like I have a friend who like started off as a math major, but he's moving into being a physics major because he just likes more of like his physics classes. He finds that more engaging because there is like such a mix of math and physics in physics, right? So he just found like the application of that math more interesting in physics. So I think like your classes are going to be a big part of it, but also just more of like what you find like figure like is interesting to you. It'll be like an easier decision to make there too.
Juan or Ben, I think Salvi's already mentioned that in his introduction. So I don't know if Ben or Juan wants to add something.
Yeah, I also came in, I was leaning towards physics. I wouldn't say I was dead set on it, but I just really enjoyed the physics courses that I took and was like, yeah, I enjoy another 3 years of this plus beyond. So that's how I knew that physics was the right thing for me. To go off of what Regini said, it's basically just off of your experience in your first year courses. And if you find that, yeah, physics is really fun, I really enjoy this, you know, it keeps going, and it's the thrills of first year physics courses. They don't stop there. It's been fun and I really enjoy it. And alternatively, if you're not having a great time in physics, then the university and CSE have a wide variety of majors and minors available that you can find a program that's best for you and that really fits your interests. And for me, that was physics. So
Juan, do you want to add something?
So I started off as astrophysics, and it was an all right pace, but there was it like as everyone said, it takes a few classes or a couple more classes in advance to maybe realize like maybe, oh, you really like this, or you really hate this. And for me, was quantum physics was like, oh, okay, this was an enlightenment. I actually really enjoy this, this realm of physics. So I was like leaning more into physics rather than astrophysics. But I kind of want to like do it like a little bit in between or something. But so that's where I kind of like, okay, I take some physics courses as well, which is what I'm doing at the moment. And that's kind of like everyone said, it takes a couple courses maybe to see that enlightenment, so to speak.
So we are going now, I'm going to slowly merge the panel also to questions that we have for the faculty, for Shaul, Lilia, and I. But of course, feel free to continue asking the questions to the undergraduate students. I'll ask everyone to stay here on the panel. I think there's a question here that Shaul is the person to answer. I've heard of undergraduate students getting to tag along to professor-led research projects in places like Antarctica. Is that the case? And if so, what's the best way to get involved?
Yeah, so first, just before I forget, there was a student earlier who was asking, actually, there was a student who was asking about double major in astro and earth science. And I said I would alert Lilia to that question. So before I forget, Lilia, that was the question later for you. I didn't know how to answer that. As far as this particular question about tagging along to Antarctica, the reason this is directed to me is because several years ago, we had a project where we did go to Antarctica and launch a balloon payload. We didn't have any undergrads coming with us at the time. In principle, it's possible. It is a bit complicated. The season in Antarctica is the summer there is overlapping with the first semester here. And so you would have to miss a semester. And I guess if you are key to the project and you have skills that are necessary, you would get to go to Antarctica. I wouldn't quite call it tag along. NSF, the National Science Foundation that controls access to Antarctica, they're very particular about who goes, why people go, why they go there. So while you may work on an experiment like mine or like another experiment here that is stationed in Antarctica, and you would contribute to it, you may or may not actually get to go. So, but you might. It's a possibility.
All right. So Lilia, maybe you want to answer that question that Shaul mentioned about double major in earth science and astrophysics, and also there was a question about if there's an introductory astrophysics class available before you commit to the major. I know the answer, but I'll just pass this to you.
Right. Yeah. So actually, I typed in the answer to the earth sciences. And actually, no, we have not had any double majors with earth sciences recently. Maybe in the past, but I'm not aware in the last few years. But I think it would be possible. Why not? Because our students have double majored with absolutely everything, music, definitely things in STEM sciences, but also music, Japanese, I remember recently, economics. And so why not earth sciences? Yeah. And the second one about the introductory courses, yes. So we have Astronomy 1001, which is a very general overview course. It's algebra based, but it's not calculus based. So it's very, very, very basic course. If you want something slightly more advanced that has calculus, then I would recommend 2001. And that is, in fact, the 2001, AS 2001 is the first course that you would take for the major as well. So those are your two choices.
Can you take 2001 as instead of 1001?
Yes, it depends on your level of prior preparation. So yes, you can take 2001 if you're reasonably comfortable with some calculus. If you're not, then 1001 is the way to go.
And Lilia, following up a little bit about the earth science, there is some overlap, right, of research interests with earth
There
science.
is, yeah, on the planetary scale, yes, there is some overlap. Yeah, in that sense, yeah, a lot of our faculty is engaged in research that has to do with sort of stars, galaxies, and the universe. But there are some that do planets as well, and that's where the overlap with their sciences would be.
Any more questions that you have for the students in the panel, for the faculty in the panel?
There was a question early on, Raphael, that I answered and it disappeared from the log about, is it recommended for astrophysics students to also do a physics major? And I thought that might be an interesting question for other people. And so I think what I responded was that it is not necessarily, it is not recommended or not recommended formally, either by physics or by astrophysics. It depends very much on your long-term goals, if you know them. And I think people have opinions, personal opinions. And when students ask me personally, I would say, if you can do the double major, if you could spare the time, if you could do the extra classes, however they may be, do it. It is a more enriching experience, and it might be more valuable for the long term.
And double majors with physics and astrophysics are very common. Very many students do that. The ones who are astrophysics majors choose to double major with physics as well.
In the same line, Samantha asked, I saw earlier that it's common for a computer science major to double major with physics or astrophysics. Is there a particular reason why do you think, or it's just by preference or interest of the individual? Yeah, I mean, I think as Shaul said, right, it does boil down to your preference and your interest in your long-term goals. We do have a computational physics emphasis where certainly there is a lot of overlap with just, if that's your interest. If your interest, you really like computation, really like to apply to solving scientific problems in physics, right? That is the emphasis. And yeah, there are people that do double major. Now, it doesn't mean that only computational physicists will double major of computer science. We could also have the professional or the astrophysics. Lily actually referred to that earlier. It's not uncommon. So in the end, it is a matter of preference. There are, Lily mentioned, there are double majors in a lot of different majors. It is really a matter of what you want, what your long-term goals, and as you progress along your years here, what you find interesting, what you want to pursue, as our undergraduate panelists also said. Okay, I think we're getting close to the end, but do we have any other questions or? Sorry, I started saying and I mute myself. Yeah, today is not a good Zoom day for me. So I know it's here getting close to the end, but I wanted to ask if there are any questions. And I also want to ask the panelists if they have any other thoughts or anything else that they would like to share with the students. And I also wanted to say that feel free to email any of us, okay, with questions. If you just want to stop by and chat a little bit more, we're always happy to talk. But again, I don't know if any panelist has any additional comments or thoughts.
I was looking at the Q&A and there was one question about minors. And I think Lulia answered this too with like some, and she said that some students choose non-STEM fields as well for minors. I have one of those. I added a communications minor because I'm really into science communication. So I'd say like a great place would be to, like, if you have other interests, like talk to your advisor and see what else you can do and what other minor, like they don't all have to like be STEM fields as well. So it's like a good addition to your physics or astrophysics major.
Okay, does anyone else wants to say anything? Otherwise, I think we're getting to the time to close the Zoom webinar. Again, well, we're glad that you're here, that welcome. And again, please reach to us if you have any questions, okay?